Good morning, everyone. Thank you for joining us for another Power Hour. Today, we're going to be covering IEC 61131 and a bit of logic crack TC split function we've added recently. My name is Johannes Halamariam, and I'm joined by Brett Donjon. I will be covering the IEC 61131 part. I'm going to start with introduction to IEC 61131, and then I'm going to do a live demo with NCD. I'm going to connect to Orion and show simulation. And Brett will cover the logic pack review, basically the typical split function. If you do have any questions, please type your question on the question tab on the on the webinar setting. There's a questions tab down there. So IEC 61131 is a set of programming languages defined for PLCs. So if you've done programming with Allen Bradley, Modicon, or GE PLCs, you've seen at least some of these languages before. There are 5 different languages in IEC 61131. There's ladder diagram, function block diagram, structured text, and the structure list, sequential flowchart, or SPC. And each program can be configured as a main program, or a subprogram, or a user-defined function block, or a UDFB. So if you have a code that's reusable on a different program, it'd be good to make it a UDFB. And then you have a child of SFC or sequential flowchart. One of the main reasons to use 61131 is the fact that you can simulate the program online while it's running in the Orion, or offline while it's running in the an NCD. And the way it runs in cycle constantly unless it's instructed to stop. What makes it that's one of the reasons what makes it different from Lua and Basic. In Lua and Basic, you have event timed or timed ways to start your function. And 1131 it runs consistently in cycles. Once you create a 61131 logic and NCD, it creates a .ncz file. It's basically a compressed file that you cannot open to edit in text. This is an example of a ladder logic. Ladder logic runs between rails. So you have your left rail and your right rail. Like on the example you're looking at right now, you have a contact. That's what's called a contact. The gap right here is a contact. And then you have a function, and then you have a coil. On this example, if the coil is triggered, it runs the timer, and then the timer turns the coil on. It's easy to follow, and that's the reason why a lot of people use it. You can also do maths in 61131. For example, on this function right here, the timer enables the maths. The function runs, and if N1 is greater than N2, then it turns the coil on. Things like that. And this is an example of a function block diagram. A function block performs operation on connected inputs and outputs. So you have an input coming in, the function runs, and then it outputs. It's very straightforward. You can combine multiple functions. And this is an example of what a structured text looks like. If you are going to do a structured text, I think it's preferred that you do it in Lua or Basic, because that's a lot easier to look and monitor and see what you're doing. So I haven't seen any customer that's using structured text right now in 61131. Most customers use ladder logic or function block. But if you are using structured text, you do have, the if then else, the do while, the for, and so forth. And then we have an instruction list. The instruction list looks more like an assembly language. If a program is written in IL, the language is list of instructions. Each instruction is written on the next line of text. And then we have SFC. SFCs are made of three basic elements. You have steps, transitions, and functions. And I honestly haven't seen any utility currently using SFC, so I'm not going to cover a lot of time on SFC. But if you do have any questions, you can send it to us, and then we'll answer later on or when we send an email out. When you configure 61131, this is the window you get. So you have your toolbar, you have your programs, you have your functions, you have your variables, and then you have the editor window where you spend most of your time. In 61131, almost everything is considered a variable. So you have your variables like your points you mapped in, the virtual inputs, the virtual outputs, those are all variables. But also your timer is a variable. If you use a timer in your logic, you would have to go in and define that variable. Function blocks are the same way, they're variables and counters and so forth. This is what the toolbar looks like. So from the toolbar, you can go simulate online or offline. You could build a release before it can be run. You can also decide if you want to build a release version or a debug version, but that's actually configured under settings. I'm gonna go back and do we go online. I'm gonna show a little more what to do, how the settings part works. And like I said before, one of the main reasons why most customers use 61131 is the fact that you can simulate online or offline. And that's what the program window looks like. In the program window, you can create a new config file. You click on the create a new program, and it pops up the new program window. That's where you put the name of the config, the name of the program. And you could choose function block, ladder logic, structure text, or whatever you're looking for. By default, it starts with FBD or function block diagram. And the execution mode is main program, where what you use most of the time. And then you have a subprogram where you can call the subprogram for another main program. Or you do have the UDFB option where you can write functions or logics that could be used in different, say for example, feeders. If you have a reclosing scheme and you don't want to do it for every feeder, you can create a UDFB and then you can use it over and over instead of writing the logic for each of the feeders. And I'm going to show a little bit how that works. And then in the function window, you can click on any of the functions. It pops up a help window. So the help window will tell you what types are, what data types are required for each function, right? For example, like for this one you're looking at, it tells you what the inputs are and how they work. And if you do need more help, you can open up the manual. The manual shows you a little more instructions and how the functions work. And the variable window, this is where you map every point that's being used in 61131. If a point is not mapped in 61131, then you won't be able to use it in your editor or your logic. So the first two tabs are your real points, the inputs and outputs. Those are points that are coming from another logic port, or they're coming from an IED that the Orion is talking to. The next two tabs, the virtual inputs and virtual outputs, that's where you create points in 61131. So logic points that you can use. And once you create them, the name will have at IEC at the end of it. So that's the IEC 61131 point. Once you map the points in, you can modify the name, what it should be, under the name under the IEC 61131. And you can use, that's the name that you use in your logic. Another thing to pay attention to is types, data types. So for example, if you map in DIs, they are usually booleans, not integers. And if you map in analog values, they could be int, dint, and so forth. Make sure whatever you're mapping in is a correct data type, because when you map it to the function wants to see the right data type. I've already mentioned 611 programs are run continuously in a cycle, and that's they're not event driven like Lua or VB. The way they run, they go from left to right, and then when that's done, they go from top to bottom. And like I mentioned, ladder logic is defined between the power rails. Contacts functions are executed from left to right and from top to bottom. This is just showing you a contact and a coil. So if you map a point in, you force the contact, the coil triggers. This is an example of an ORed contact. So if any of the points are on, it turns the coil on. And if you double click on that coil, it gives you all the available points in 61131. Kind of like this. So double click on the contact, it pops up a window with all the available variables, and then you can expand the variable, and the variable will show you all the attributes of that point. For example, on a contact takes a boolean. So you can use the online offline status, or you can use a value, but you cannot use a chain, text, date, or time. This is basically a dumb program where it shows you if any of the count fail points are on, it turns the global count fail point to high. Let's go back to here. And this is the project settings window. This is where you set up what if you want to do a debug or release mode. This is where you set up if you want to use SSL. This is where you set up if you want to force the points that are created in 61131 to be online. You have the option to build your project as a debug that gives you an option to step through your code. So if you have an error, you can put a break line in, and you can step through every code to find out where error is happening. If there is a problem with your code or your logic, when you simulate it, it'll give you a failure, and it will tell you exactly where the failure is happening using the row and the bar. So right now for this, it's 1-0. And I'll show you when we go live how that works. If there's no error with the program, it'll tell you it's successful and no errors detected. Now it's ready to be downloaded onto Zorride. You can simulate offline while it's running an NCD. While you're simulating it, you can force the contacts to whatever you want, and then you will be able to monitor the value of the points and the data inputs. Like if you go to the inputs tab while it's being simulated, you can monitor if it's changing to the correct data or to the correct value. (61131) is designed for PLCs. So PLCs commonly don't use communication protocol, right? And if they do, it's their own communication protocol, and sometimes it might be Modbus. Say, for example, you want to control a DMP point on a device that's connected to the Orion. If you want to do that, you will need a way to communicate to that device. That's why we came up with Orion functions called this Orion functions. So we have get point, pulse output, set point, and trip close. Get point obtains the current value, the online status, or the number of changes from from the Orion real-time database. The pulse output is used to pulse an output point. The set point sets the current value or the online status, the number of changes of a point. And trip close lets you send an output, send a trip or close to an output point. So if you're using an Orion IO and you're doing 61131 on the Orion IO, your controls are going to the Orion, the built-in Orion IO outputs. You do not have to use the trip close or the pulse output. You're only using this if the Orion is communicating to an IED and you want to send a control to that IED. I'm currently working on a tech note and how to configure this, and I can send out to anybody that has any questions. I will do a live demo on one of those functions to show you how it works. We also have an option to import programs from one config file to another config file. So if you did an NC program with 61131 for substation A, and then you want to do the same thing on substation B, and instead of recreating it, you can actually import the program from the old NCD to your new NCD, and then use the same logic. Okay, let's go to the live demo. So let's start a new config file. Orion LX Plus and configure logic and IEC 61131 resides here. So like I said earlier, this is what the interface looks like. The main one that I want to mention under settings. So if you select a debug, the code generator will be a debug version. If you do a release, it'll be a release version. If there are no errors, you could download it to Orion. The show context help. So that option right there, the way it works, with all the functions we have, if you double click on it, it gives you help on how that function works, what kind of inputs it takes, what kind of outputs, and then the data type. But if I go into settings, if you're annoyed by that, you can disable that and you double click on it, it doesn't give you anything. But it can still hover on top of it and it will tell you what type of inputs and outputs it takes. I'm going to create a program with a contact, a timer, and a coil. And I'm going to show you how that works. But first, I'm going to map some points to use in this port, in the IEC 61131. I'm going to map the Orion's own built-in IOs. So ACR inputs, I'm going to map in the DIs. And then outputs, I'm going to map in output 1. Let's make this one TC. And then I'm going to map this two to be just latch, or one of them to be pulse. So now we can use these points in here. The points I mapped are showing up here. We need to map them to 61131. Now we can use these points. We can go to outputs and then do the same thing. One of the things that you could do is you can actually double click and change to 61131 name. So if I want, I could say this one is feeder 1 _ trip. And I can go in the input, same thing. If I want, I can say this is breaker status _ feeder 1. All right. So if I do want to create a new program, first thing I will do is click on create a new program. I'm going to give it a name. I'll call it demo. By default, it will say function block diagram, but I'm going to do ladder because I'm more comfortable in ladder logic. And I'm going to make it the main program and hit OK. So when you do that, it gives you the tools that you could use to create your contacts, coils, comments, and so forth. So I'm going to start with the first one. That gives me a coil and a contact. Okay, so say for example, if I want to monitor a breaker status and control a breaker, I could just map that point. Make sure you map it from the 61131 name. So map it from the 61131 name, and then I'm going to go to the output tab and map in the trip. And if I just simulate it here, there's no issues. I'll ask you to save it first. Just one. So now it's running, right? I can force it by double clicking on the contact. I can force it to be true or false. If I force it to a true, boom, the coil goes high. And that's what makes it easier to work with. You can see exactly what's going on, kind of like a circuit. So I can simulate, right? So I said I'm going to do a timer. So let's add a timer in there. So timers are located under timers, and I'm going to use TON, an on timer, and just drag it in. And I think, okay, I'm going to delete this and then come out here and add a contact. So I got my timer now, I got my contact and the coil. So the first thing that I need to do is declare or define this timer. To do that, you go to variables, right click on demo, add variables. I'm going to name this one T1. Then if you expand your program and you see the T1 that you just created, but it's a wrong type, we need to make this a TON type. So go all the way down to TON, and now it's done. Now you could drag that timer onto that. The next thing we do is we put the time. How long do we want the timer to go for? So if I say I want it for 5 seconds, I can just double click right here. I could do 5 S. So we did a time pound 5 second. If I would have put 5 T pound 5 second here, it would have made the same thing. I can create a variable and use that variable in here instead of doing what I'm just doing, what I did, just put the 5S in there. You can also add a lapse of time, right? So to monitor the lapse of time, I can go to virtual inputs, create a point. So I can say ET, and I want to make that 0 to say 100. The data type automatically selected L real, right? But if I hover on this, it tells me the data type for ET is time. So I'm going to click on this and select time. Now that point is ready. So I can map the IEC underscore ET to the ET slot. The only thing that I have left is a contact. If I go ahead for the contact, I map in the breaker status. That would work. So I can simulate it. There's no issues, so it's running. If I go ahead and force the contact to be true, I can monitor the elapsed of time counting up. 1, 2, 3, 4, boom, and the coil is on. All right, and then if you look at the output that we sent, that's output 1 here, feeder 1 trip, you can monitor it under the outputs tab if the right contact has been triggered. We do have, like I said, a whole bunch of different functions. So if you want to do, say, for example, ORing and ending, you could do it on Logic Pack. Or if you want to do it here, you go to the Booleans. And say if I want to do the OR, just drop it in. Right now, I only have 2 inputs. I could double click on the OR function, and I can increment the inputs from 2 to 4. And then like we did earlier, you could just map the point you want to monitor. the thing about the or the and, the function are already defined, so you don't have to go in and create a variable for them, but because they're already created, so you just leave that alone. But that's how oring and ending works. It's very easy to set up. The next thing that I want to show, I can actually download this config file onto the Orion and show how it runs while it's in the Orion. To download it, first I'm going to go ahead and settings. I'm going to disable the SSL because I don't need it. I'm going to hit OK. Second, I'm going to go hit download the config file onto the Orion. So there's multiple ways you could download config files to the Orion. Use a terminal or the web browser. I'm just going to use the terminal for now. Communication online connection. I've already created a connection between the Orion and my computer. So it's 192.168.0.6. Connect. NovaTech. NovaTech. So I'm going to so like I said earlier, it created the .ncd file and also created the .ncz file. But it's telling me was that error that the config file is not saved. I think it'll ask me if I want to save it. Hit OK. Do you want to save them? Yes. And I'm going to make this config. I'm going to check. Oh, I didn't accept it. I had to accept that. So let me save it again. File, save as, that, continue anyway, and save. Now let me send that config file again to Orion and make that config file active, option 3. And it will be IEC demo 1, 11, and then make it active. Okay, my Orion is up and running. Now, the config file is running in the Orion. I could just go simulate, or I'm sorry, go online. So I'm going to select the IP address of my Orion. And the reason it's showing up here as available SSH connection, you can't create one here. You would have to first go to communication or line settings and create a new connection. Once you create it on this page, then when you come out to go online, it will show up here. So I'm going to click on the Orion that I'm working with, and then I know it's NovaTech, NovaTech. Okay, so let me confirm that my config file is running. NovaTech, NovaTech. Yep, my config file is running. Now I can go ahead and go online. That's NovaTech, NovaTech. Okay, now it's working and it's running in the Orion. So kind of like how I was doing offline, I could do the same thing here. While it's running in the Orion, I can force my inputs. And after 5 seconds, that should go high. And I just heard the relay and the Orion Alex Plus click. So I know it's working. So like I said, that's a really cool feature that 61131 has. Okay. The next thing that I'm going to show is, okay, say for example, you have a program you don't want anybody else to change. You can right click on the demo, go to program properties, and then if you go to security, you can actually set up a password on the program. So if you're doing, like, for example, a UDFB, you don't want anybody else to go in and change it because you're using it on every feeder. You want to put a password username. The reason it's grayed out right now is because the program is open. You can just close it by clicking on there and then right click, program properties, security. Now I can put a password on that program. Okay, that's one. Another thing is you can right click on the program that you're working with. You can convert it from ladder logic to whatever type of logic you're comfortable with. Was it structured text, FPD? It's up to you. I told you can import config 6731 logic files. You just click on that, and whatever is available, it'll be here. And like on this one, like I have this that I did on a different project. You can, I don't know if it's gonna work, but let me try it. Hit OK, right there. The TC demo that I just downloaded shows up here. Okay. I'm gonna delete everything I have for now. And let me start a new program. Now I'm going to show you how to use those Orion functions that we created. So let me create a new program again, import program. No, sorry, create a new program. I'm going to call it demo again. And let's do ladder logic, main program, hit OK. So say, for example, how does the trip close work? So first, I'm going to drop the trip close out here, okay? The first thing you need to do is define your trip close function. So if you double click on the 3 question marks, and then you say, for example, TC1, hit enter, it'll ask you to declare a variable. So it's already TC1, already picked the right type, trip close, and the file, the config file we're working with, or the logic file we're working with, a demo, which is right there. So you're good here. So you can just hit yes. So that's created. The next thing is, if you hover like I just did, it tells you the inputs for each one of those, right? So the name takes a string, the ctl takes a boolean, and the on takes a boolean as well, and the output's a boolean, but we don't care about the output. Don't have to do it. For this string, the common mistake that I've noticed, customers think they can just map the output onto the name and it would work, but it doesn't. The way it works, first you have to go to variable and click on the config file you're working with and create a data type. Oh, I'm sorry. Create a variable and say, like, for this one, let's call it feeder1 underscore TC, right? And if you maximize this, this is where it is. And I need to tie it to the right variable, right? So like I said, the name requires a string. So I'm going to go to the string, click on the string, and the string data type is set. The next thing I need to do is I need to point this variable to the actual output. So I can go ahead and type the actual output as an initial value, or I can go to the outputs tab and click on the name of the point, right click, copy point name, and then I'm going to go to variables. Now I can right click and paste. So the string that I created here is tied to the initial value of output 1 ACR, right? Now I could drag it onto here. The next 2 inputs we're working with are the CTL and the on, and they're both Booleans, right? At CTL runs or triggers the function. On is the actual value you're sending out, true or false, or 1 or 0. 1 for close, 0 for trip. So I can go to virtual outputs, and so I already have one that I created. There's a run in there. I can use that run. This is the Boolean point, and then I can create the value. So I can use this value 1, or I could say val2. You know what? Let me name TC val. You know, val2 is okay. That's okay. And make sure it's a Boolean, right? Boolean, and now we have this Boolean we can map to here. So this is the actual value, a 1 or a 0, going on to the IED. This is what triggers the function, and this is the output we're controlling, and trip closes a function which we call TCY. So how do we simulate this? See how it works. There's no issues. It's working, and I can look at my outputs. Right now it's a false, so I can force a 1 or a 0. So I'm going to force a true, and then I'm going to trigger the function. And as you can see on the outputs, on the data outputs, you see it went to true. So this Orion functions, they're a little more complicated to deal with. So I've done a tech note. I just started putting it together for a customer. So I have a tech note on how to set them up. Yeah. So I have created step by step of what you need to do to configure. So if you have any interest in this or you want to do it, you can email us and I can send you this tech note. And all four are pretty much similar how you set them up. Next thing that I'm going to show how to do UDFB. Okay. Say for example, so let me start a new file. Configure logic and IEC 61131. Let me configure the hardware points that I'm going to use. Okay. So when do you use UDFBs? So if you're using like a recloser scheme or auto changeover scheme, it's the same from feeder to feeder, and you don't want to do the same thing over and over. That's when you create the UDFB once, and you call it on your main program. Okay. So the example that I'm going to do a simple one where you're monitoring count failed points from substation A with 5 or 6 count failed points. If one of them is on for 5 seconds, go ahead and send a control out or set a virtual 61131 points to high, and we can map that point to SCADA master. So create a new program, and first I'm going to call this count fail, and it's going to be ladder logic, and it's going to be UDFB, and hit OK. When this is where you put the points in. So basically, you double click on the 3 dots, and you map in the points you're going to use. So count fail 1, and count fail 2, count fail 3, count fail 4. And then we're going to do just one output. We're going to call it count trouble. And that's a Boolean. We'll leave it at that and hit OK. Okay. So first, I'm going to OR all my count fail points. The variables I created right now are under count fail. Okay, they're all Booleans. So first, I'm going to do a Boolean, and I'm going to map in an OR gate. And I'm going to double click on the OR gate and then extend it to 4, hit OK. Okay, and I'm going to map in this 4 points I'm going to monitor. Okay, so if any of them are on for over 5 seconds, go ahead and set a logic pointer. So I'm going to go ahead and get a timer again, tune in, get a tool in, and then put it here. Okay. And I'm going to define my TON. First, I got to go to variables, confill, add a variable, T2, and then tie that T2 to the right data type. That will be TON. And map that into here. For the time, let's do 5 seconds. And then if one of these points is true for 5 seconds, go ahead and set this point on, the count treble point. So I'm gonna map the count treble point on. So now, I don't wanna do this over and over. So if I wanna use this function on my main program, I'll create a new program, and I'm gonna call this confill underscore UDFB. And, oh no, I'm sorry. This is going to be the main program. Sorry. Demo, ladder logic, main program. I wanted to do a ladder logic, sorry. Demo, ladder logic, main program, leave it on there. Now, I could drag this confill UDFB onto the main program, right? First thing you do is you define the, the UDFB. To do that, you go to variables, right click on demo, add a variable, and you can say set a confill. And hit OK. Now I'm going to tie this variable onto the UDFB we created. So I'm going to click on this on the type, and that confill is right here. The next thing I'm going to do is map in the real points. So assuming these 4 points are the confill points, I'll just map these points in here. And then variable UDFB confill goes right here. So if any of these points are on, I can turn a coil on, and that coil could be tied into like confill major or whatever, and the map that point to SCADA master. So you could do this over and over for different things. So I can add another one, and then I can add another one. So if you're doing a recloser status or auto changeover logic, whatever you're doing, and you create a UDFB, what makes it cool is you can use over and over. You don't have to do the logic you did on here over and over. So it makes life a bit simpler. I think that's what I have for now. Brett, you want to take over and do the logic track?
Yes, I can do that.
Okay. Let me give you control.
Okay, so you should be able to see my NCD screen. And as Johanna said, I'm going to be showing the trip close split function in our logic pack module. And I'm going to introduce that by saying that this particular feature, the trip close split, was released. It was added to NCD in version 3.37, and that's from our well, that was our version released in late 2021. So some of you, it's been around about a year and a half, so some of you maybe have seen this already, but I'm still going to go through it and present it in a way that should be pretty easy for you to understand if you're not familiar with it. So I've got a file open, and I'm just going to show you. I've set up an SCL client, so I would have this communicating with an SCL 351 relay. So one thing to say about the trip close split functionality, again, before late 2021, when that version of NCD came out, we would have to incorporate this trip close split functionality in a different way. I guess typically you would do that through some of the other logic modules. I actually set up a program using Lua programming code in Advanced Math and Logic. So I'm going to open this up, and this should give you a pretty good analogy to show you how that function in Logic Pack works. So if you take a look in here, you'll see a few lines of code. It should, if I talk about it for a couple minutes, it should make perfect sense. There's not a whole lot to it. So the function is called trip close split, as you can see right here. And what I have this point right here, this AML, or this is advanced math and logic trip close split point for feeder 1. You can imagine this as the control that you would receive from a client device, let's say your SCADA, and it would be a command to trip or close, where we'd presume that a 0 value means to trip and a 1 value means to close. So this trip close split function, as you can see, and I'll show you this real quick. The way you set this up in advanced math and logic, the event is called trip close split. That is tied to the function, and the event type is refresh. And what this means is that whenever a new value is asserted to this point coming from your SCADA, whenever a point is pushed, it triggers this function, this code runs. So let's say that happens, you receive a control from your SCADA on that point. First, there's a variable here, gets the value of that point. So you see that point name dot value. So that captures the point value in this variable. And now we're gonna ask essentially if that value is a 0 or if that value is a 1. So we're saying if it's less than 0.5. In other words, since this is a binary point, if the value is 0, which represents trip, we're going to assert the trip control point, which we're calling RB1. And that's a point on the SCL 351. So if it's a 0, we're going to set this trip control point to a 1. And there's an else statement here too, where if it's not 0, meaning if it is in fact 1, which is tied to close, we're going to assert this RB2, which is your close control point. So to summarize, just depending on if this value comes in as a 0 or a 1 determines if a trip or a close is asserted, and that split and close, or sorry, that trip and close are asserted on 2 different points. There's the trip point and the close point. That essentially is the way you would have set it up before Logic Pack was added to NCD. So now I'm going to show you how to add that same functionality now with the features on Logic Pack. So I'm going to create Logic Pack. I'm going to go under Logic Outputs because it is in fact an output. And at the bottom, you'll see these choices. There are 4 different functions that we can run here in Logic Pack, and we're going to choose trip close split. You click the plus sign to add a value or add a point. Now we're going to give this a name. Now it's going to coincide. It's going to be similar to that advanced math and logic point. I'm going to call it Logic Pack trip close split on feeder 1. So now once I've named the point, this serves the same function. This would be a control point coming from SCADA where 0 is trip and 1 is close. So now it's a simple drag and drop. This was trip, RB2 was close, and that's all we have to do. As you can see, it is much, much simpler than incorporating it via advanced math and logic where you're typing programming code. It's even simpler than how you'd incorporate it through the function blocks as Johannes was working with. So that's all you have to do here. And before I conclude, I'm going to go ahead and show you how this works. So first, I'm going to save the file. I'm going to send it to NCD, and I'm going to do it the other way. Johannes had sent it through the command or the console. I'm going to send it through the NCD web UI. So I'm going to go under Files. So this is where you send the files. I'm going to select these 2. Note that there's an NCD file. Now we had that in advanced math and logic, so there's a Lua file also. I'm going to go ahead and send both of them to the Orion. And I'm going to change the active config. Since we're adding that file to this Orion, I'm going to select TCS demo, and I'm going to activate it. So now my Orion's doing a quick restart. Once it's done doing that, I'm going to set up a simple test. I will load data values. Here is where I will send the points, and I will send it from Logic Pack. So you see my point right here. Again, this is the point that would come from SCADA. So now I'm going to take the data values on this SCL client, and I'm going to look at the outputs here. Remember, RB1 was trip and RB2 was close. So now let's say a point comes in from SCADA. I can simulate that by forcing a value here on the web UI on the Logic Pack. So if I force a value 0, you would expect RB1, which is trip, you would expect it to force a value of 1. So we'll click force value, confirm, and you can see right there, last output changes to 1. That's because we just asserted a 1 to RB1. In the same way, we can assert a value of 1 here. 1, of course, represents close. And I can force this value, and you should see RB2 assert. So the way these are configured, I have them configured as a simple, 1,000 millisecond or 1 second pulse. So again, note, these are not sustaining values of 1. Just it says the last output that was asserted was 1 here and then 1 here. So that's pretty much all there is to it. We just wanted to show you that in case we hadn't had an opportunity to show you this in Logic Pack. Of course, it also fits nicely with Johannes's demo. So with that said, well, that was a pretty quick demo, but that's really all there is, just to show you how simple this functionality in Logic Pack is, how much easier it is than kind of programming it manually through other logic functions. And that is really all I had to show you. Johannes, do you happen to have any questions or anything I can show on the screen before we close out, or do you think we're good to go?
No, we're good to go.
Great. And for anyone who submitted questions, maybe didn't get an answer, keep in mind, if you submitted a question, note that we typically send an email out after the webinar to all attendees. It'll include questions and answers. So if your question was not answered through that email, it will be. And of course, if you have any questions on top of those, you can feel free to reach out to us at any time. With that said, I'm going to go ahead and close out the webinar. Going to conclude it. Let's see. There we go. I'll conclude it as we always do by showing you a reminder of our customer community, a redesign of this community a few months back. The customer community is now rolled into our main website. So you can find this community at NovaTechAutomation.com/community. And you can see just on the front splash of this page, there's a list of recent webinars. You can just check what the latest version of the software is to make sure you're up to date. And then there are some support options here, different ways to get in touch with us with questions. And as we always do, I'll show you booking a call with an application engineer or the sales engineer team. This is incredibly useful. We have a lot of people using it, but the premise of it is, if you'd like to schedule some time, if you have questions or need us to maybe show you something real quick and you'd like to set up a meeting, you can come here. This is actually tied into Microsoft, where you can pick your date and you can choose a time that works for you. And you can select the staff member that you'd like to speak with also. Again, all of our names are here. My name is right here, and you'll see Johannes as well. You can choose a time slot, pick a meeting time that works for you. If you don't have a preference on who you speak with, you can choose anyone. And then, of course, our team will get someone on the line with you, whoever is available at that time for a meeting. As I can say, we like to remind people every month, this is incredibly useful, and it's a good time to get some face-to-face time to get questions answered. So it's something we're very proud of. So with that said, I will conclude the webinar right now. Here's contact information for Johannes and myself. And in closing, everyone have a great rest of the day and take care. If you have any questions, feel free to reach out as always. Thank you.